Hello everyone, it's great to be here. It's actually a huge thing for me to finally be able to present the tool that I released about a year ago. It's mainly a phishing tool, which main purpose is capturing credentials and also cookies, which allow to later bypass two-factor authentication, which is like the main purpose essentially of this tool. So first thing, I wanted to see if you can raise your hand, how many of you have two-factor authentication enabled on any of your accounts? Yeah, so that's what I thought. So I'll also try to show you that it's not really, it may not be a silver bullet in securing your account. So a little bit about me. I'm a security researcher, software developer. This is my face. My name is Kuba Gretzky. I don't play hockey, sorry. And I work as an independent contractor. I'm mainly programming in C, C++, recently Go, and I also do some low-level assembly programming if it needs to, if I need to do any custom shellcodes or anything like that. I started about, 15 years ago. I started by hacking massively multiplayer online games. I used to do vulnerability research on the network protocol and also was writing automation tools, which are called bots, essentially. So I have a security blog that you can check out. I post there sometimes, sometimes not. Essentially what I do is I do offensive tools, development tools for red teams, aiding red teams to capture all the flags in the company network. And my specialty is evasion of antiviruses and EDR products. So what is Evilginx? Evilginx is mainly a man-in-the-middle reverse proxy, which basically works in the middle between the user and the legitimate server. It's proxying all the data that's coming from the user to the legitimate web server while capturing all the content. So it captures the requests and the responses back that come from the server. It separates you may ask, how can it intercept data if it's TLS encrypted? So it actually manages two connections. Connection is between the user and the Evilginx server, and also between the Evilginx server and the legitimate website, which is for example, Outlook, Google, or whatever. So later I'll show you how it basically bypasses two-factor authentication by capturing the session tokens. So the origins, I checked the proxy pass feature in Nginx HTTP server, and that actually allows you to forward all the requests to the web server to another web server. And I thought, would it be possible to actually capture this request, and before actually sending it forward, would it be possible to capture the logins, and also when the response comes back from the external server, would it be possible to capture the cookies, which usually contain session tokens that you can intercept. So that's when I had the idea to release this tool, and the name is of course from Evil and Nginx. So it's Evilginx. I don't know how to pronounce it properly because some people say Evilginx, someone says Evilginx. So whatever you want to use, I won't care. So the first version I released was in 2017. I found a version of Nginx. It was an open REST kind of the version that was called, and this implemented a Lua scripting language into the Nginx configuration files. So I thought of using actually this Nginx configuration file with Lua scripting to intercept the data, put it in the log file, and then have an external Python script that actually parsed these log files and dumped the information to a separate file. It was really not fun to use. It worked perfectly, but it was more like a proof of concept since Nginx was never supposed to do anything like that. So that was the main issue. So later, I found out that Go language exists, and Go language is actually amazing. If you are into offensive tools development, I highly recommend you to check it out. It's really awesome. Please do check Bettercap because I've gathered huge inspiration from this tool. It is extremely well written. And you can probably learn as much as I did. Really great tool. There was also in use a Go proxy library, which is Essentially, Go has libraries, and you can almost find library for anything that you want to use. They have like DNS servers, HTTP servers, WebDAV servers, anything you want. And the Go proxy library did essentially what ProxyPass did in Nginx. So I didn't have to write it all from scratch. I could just reuse what I had, what they had, and implement it as basically ProxyPass as a standalone tool. And I didn't have to use Nginx anymore. So, short information about how phishing looked like back in the old days. Essentially, it's just an HTML template that you put you host on some web server, and it's only able to capture username and passwords. It's Scooter once said, "How much is the fish?" This is definitely a cheap fish because it doesn't take much effort to do. So so the cons of it is you can't verify the entered credentials, so the user can just type in whatever, and of course, then you cannot check if the information is correct. It looks fishy. It doesn't defeat two-factor authentication. Pros? Probably not. Well, it's cheap. That's the pro. So the new age of phishing is actually to use this reverse HTTP proxying, which exactly mirror the real website, and they transform the whole UI transported to the user who's actually trying to access the phishing site. And it captures username, passwords, and cookies as well. So the pros are, it captures the session tokens, and it contains a fully functional mirrored website. That means you don't have to play with HTML templates. You don't need to do anything yourself. Everything is just proxied through as it is. The issue is, though, you need to host it on your own domain, phishing domain, and actually JavaScript code is able to detect the domain in the URL bar of the web browser. And that's the issue that I will show you later. So now we go to the attack phase. So I prepared the live demo. Hopefully the demo gods are on my side today. So what I'm gonna do, I'm going to log into SSH into the Evilginx instance that I put in the cloud. That's what the attacker does. Let's make it bigger. Okay, so one most important thing, always remember to put ASCII art in your tools, because that's the way to start every time. So basically, Evilginx is based on configuration files, which I called fishlets. So you can see there are 3 fishlets actually right now in Evilginx. There's a Google, LinkedIn, and Outlook. We will be targeting a user named Ronald Rump, who uses Outlook. And this will be our target, so I will be using the Outlook fishlet. So essentially, you need to create your own fishlet, and each fishlet targets one specific website. So here I already have it prepared. Then you need to set up something that's called a lure. A lure is like a custom URL that you later send to your target, and that's when the website opens, your phishing page. So then you can just get the URL with lures, get URL, and the ID number. This will be our phishing link, so you can already see probably here that it's not really live.com. This is the bad part. Oh, sorry. And now we go to our victim site. So our victim is actually opening. So I prepared this as a template. So this is, for example, what you get in the email. So it says there were no detected activity on your Outlook account. Please sign in to verify that it's yours. Blah blah blah. You can just do whatever you want, and they try to sign in, and that's when they see the Outlook login page. Okay, it looks like pretty much legitimate. They think. So you can already see in the URL bar. I don't know if you're able to see from here. It's not the real website, but you can see the lock icon. It says connection is secure, so everything is fine, right? So now Ronald tries to log in. Okay, he's asked for his password. And now what happens is Ronald is receiving a two-factor authentication request on his mobile phone. So I don't know if you can see from here. This is Microsoft Authenticators app, and I will click Approve. So Ronald approved the login, and he is redirected to his inbox. Nice. I'll just confirm that it's Ronald. Yeah, it is. Hi, Ronald. Okay, and as you can see, we are still at the proxied website. It's still Evilginx server, which is actually proxying as well the inbox as a whole as well, not only the login page. So that's how reverse proxy should work. So now let's see on the attacker side what happened. So we can see that there was a person landing on the main page. They entered their username, Ronald Rump. There is a password, and it says all authorization tokens were intercepted. Okay, so what does it mean? We can check the sessions, and you see we have a session line here, which we will put details of. And you can see that all the time where it was accessed, what IP, what was the user agent, and what was the landing page URL. And the most important part you see here is the one below. This is the cookie that was intercepted from the Outlook page while it was sending the response to the user. So this cookie contains the session token, which gets saved in the web browser, so you don't have to re-log in again. And this is actually what we captured. So what the attacker does. I'll just demonstrate. This is another profile of Chrome. I'll just demonstrate that we are not logged in into Outlook. This is the normal Outlook login page. I'll just delete all the cookies again, just to be sure. Now we'll use an extension in Chrome to import the cookie from Evilginx. Okay. And now what happens when I open Outlook? And we are Ronald, completely bypassing even the login prompt and as well the two-factor authentication that he used. So, going back, what happened exactly? Maybe I'll use this. Okay, what happened? So, first thing, as I said before, the connection is made between the user's PC and Evilginx server. And as well between Evilginx and the Outlook server. So that's when the request was made. It was analyzed. It captured username and password from the post packet, which Evilginx was able to get completely decrypted. Then it forwarded it to live.com, the Outlook website. Then the server sent back the response. It was analyzed by Evilginx, capturing the session cookies, and it was passed back to the user's web browser. So this is basically how it is. So here, small information, like if someone doesn't know what exactly the cookie is, it's like a small amount of information that is of key value format, and it's saved in context of a specific domain, and it is mostly used for either tracking or keeping you authenticated for the website that it was created for. Here I wanted to say it is not a new idea. I didn't invent this kind of attack, so I don't take credit for it. There are a lot of other great tools that have been released. One is Cred Sniper by Mike Felch in 2017. There's Modliszka by Piotr Duszyński in 2019. And there's the most recent one, Muraena, and together with a Necro browser by Giuseppe Trotta and Michele Oru. The last one is especially interesting because it implements the Necro browser. Is a headless browser that allows you to automatically log into the user's captured session and dump in, for example, all the inbox. So you don't have to actually do everything manually. So please do check these tools out. And now we go to the defense. That's what I want to also, how can you protect yourself from it? So from the user's perspective, of course, check the domain in the URL bar, but it's easier said than done in most cases. The other thing is use universal second factor devices. So like also Dave Lewis yesterday mentioned, WebAuth is also one of the solutions to use. And essentially, the idea behind these devices, you cannot get phished while using them. And why is that? Because the web browser sends via encrypted, well, not encrypted, secure channel to the external device, also the URL of the page that you are currently in, which is used as a factor to generate the response token that's later sent to the website. So if the website doesn't, if it's not the legitimate domain that you would want to have, it would just send back invalid token that the website will just refuse. So that's why these devices make this attack impossible. And also, if you use two-factor authentication, never use authentication via SMS. Can you raise a hand how many people use SMS as one of the options? Okay, so if you can, remove this kind of option from your two-factor authentication, because it's these days the most common attack is SIM jacking. The people just social engineer your telecom company, they create a new SIM card, and they own your phone number, and then they can generate your get security tokens on their own device, and you will be cut off entirely. That's why how Jack Dorsey, CEO of Twitter, was recently hacked as well in a few weeks ago. So if it can happen to him, it can most certainly happen to all of us. So from the developer's point of view, probably everyone knows the JavaScript object that you can access from the web browser with its window location. So this is the object that gives you information on what is the URL of the website that you are currently on. And this is heavily secured by the browser. There's no way to actually spoof it anyway. And this is what you can actually use on your website if you want to protect against tools like Evilginx. For example, with a script like this. This is, of course, very simple script. You should do something much more complex. So here we just check if it's legitdomain.com, and if it's not, we return false. But I have to also stress out that Evilginx is able to proxy all the data that's coming from the server. So if I can actually detect the signature of this script, I can replace this script as well. So if the script is too simple, I can just bypass this protection, and this is how Google's first protection was bypassed, for example. So I could just replace their regular expression with my own, and basically it stopped working. So what you should do, obfuscate it. So this is also the string obfuscation could do a little more work, and this is like come from some simple obfuscation engine on the web that I found. But if you do it like this and do it also manual, not manual, but dynamic, so that every time actually this code is outputted in a different way. That way, there is no way anyone can have any signatures can put any signatures on it, because the tool like Evilginx, it's looking for static signatures, not dynamically parsing what it's seeing. So there would be no way to actually patch it on the fly. And also, now I have a question. How many of you know about this property, base URI? If you can raise your hand. Okay, because I thought I felt bad because I didn't know about it. Okay, so generally this property is present on every DOM item in the rendered website. And what recently my Google fishlet stopped working. It was working perfectly till one moment, and I started to investigate what did they change, what went. Well, obviously they implemented something new. So what I actually found out is they take the whole. Okay, so I'll also say that this base URI is present on every item, and it says the URL of the website you're currently on. The similar way as what window location does, but it's present on every single item on the website. I don't know if you can see that, but never mind. So what Google actually does, it takes the sign-in div container, it serializes it into a string, encrypts it, and sends it together with the login request packet to the server. And then probably, that's what I think, on the server side, they actually check all the base URIs properties of this serialized object. And of course, if it's a phishing website, it won't say accounts.google.com, but phishing.com, for example. So that's what I think they changed, and actually it's very difficult right now to bypass it. Because Google uses heavy obfuscation, they use dynamic obfuscation as well, so the variable names are always different every time it actually puts out the information, sends the packets. So yeah, and the other method, you can bind the session with user's IP address. So some people before asked me that they thought that everyone does that, but actually no. If you have a Google account, you want to be able to access it from multiple devices actually. So there is no way to actually pair one IP address with one account. Banks may want to use it because banks usually invalid your session every 10 minutes. So for that would definitely work much better. But this is also very easy to bypass because in this phishing scenario, Evilginx is actually a client. So it is actually logging into the website. So the attacker could use Evilginx server as a proxy to proxy his connection through Evilginx server. So the IP of the current session would be the same. So this is essentially also pretty easy to bypass. Another thing that I haven't heard much about, but I heard that it exists, it's a TLS session resumption. I don't know if any one of you heard about this, but essentially it generates a unique session ID for every TLS established connection. So if this TLS connection breaks between the client and the server, the session ID needs to be later regenerated. And you can pair this session ID as well with the current session. So that way, every time the connection breaks, the session is invalidated and with the session token, very likely. So this is actually probably very hard to bypass from the point of view of Evilginx because you would need to use the same connection it used to proxy your data, but obviously you would want to use a different software to proxy your data. So there is a lot of development issues, but it can be, I'm pretty sure it can be bypassed, but it will be much, much harder. Also, as a bonus for any blue teamers here, I give you a freebie. Just look for x-evilginx in HTTP requests. I put like a small Easter egg into the tool that when people use it, you will be able to tell that someone is using this tool. So you need to manually like remove it from the code and recompile. But most people, most script kiddies won't do it. Okay, so who is it for? Essentially red teamers, and yeah, essentially red teamers, and it's been in use by my friends around the world during real red team assessments. My main focus is to make it production ready. So if you are using phishing at work, please use it. It works. It gives results. A lot of my friends told me they owe me beers, so I will recollect later. But essentially, there's a profit for me in it somehow. So I prepared like a shortened link for you. This points to the GitHub page of Evilginx. Also, I need to mention Kevin Mitnick was using this tool on his keynotes around the world, so it works somehow. And yeah, thank you. That's it.